So if I take, I'll show you my example. Let's say we take the number 116, and we want to go to base 6. We do the exact same thing we did converting decimal to binary, decimal to hex. So basically we go, okay, 116 is our value that we want to convert. Since we're in base 6, with base 6, 6 goes to 116, do it the long way, 6, 56, 6 goes to 56, 9 times, so we can get 4, we're going to get 2, so our remainder is 2, and then we take 19, by that by 6, 2 times 12,
It's 3.
sorry, 3. That. 18, made it 1. Then you want to put, now 3 goes in the base. 3 goes to 6 0 times. 0, 3, 3 to the remainder. So we get 312 is our conversion from decimal to base 6. So 116 to base 6 is 312. Okay. So any questions on that? Hopefully it's kind of repetitive from, as long as you remember how to do the hex and the binary, and you remember how to convert decimal to base and our base to decimal. You see the exact same formula to do that.
Could we take that 312 and go back the other way?
Yes.
Just give an idea.
So we do the same thing we did. So now we're going to go base 6 to decimal. So these are position 1, 0, 1, 2. Then I'm going to go 3 times, my base is 6, position is the second position, plus 3 times 1 times 6 to the first, plus 2 times 0 place. So 6 times 6 is 36, times 3,
108.
108. And then 6 times 1 is 6. 6 plus 1 is 6. And then 6 to 0 is 1. That's 2 is 2. So we're going to get 116. Good.
That was decimal, but
Yeah, that was
base 6.
base 6 decimal. So it took this.
Base 6 to decimal.
I can't say 312 because it's not 312 decimal, but base 6. Right.
When you convert to a binary to ASCII, though, you have to have a table, right?
Yeah.
Because obviously you can't memorize a table.
We'll get that in about maybe 20 minutes.
Okay.
Okay, so last thing, one thing, the next thing about, we're still going to stick with bits, numbers. The book called it bit vector. I like to call it bit masking. Basically, bit masking or bit vector is basically you want to test if a bit is on or off. Or you want to say is 0 or 1. So basically, want to test if the fourth bit is 1. The idea is how I can test if the bit is 1.
Is 1 on or is it off?
We're going to say 1 is on. So I'll put that on for a second. It's not true in all cases. Depends on who built the architecture you're working on.
Is that
What?
XOR? Is that what you use? Or?
No, this is a 1. I could go like this and that.
I mean, to test it, you would use
No.
a computation of some sort
Mm-hmm.
with two binaries, right?
Yeah.
One that you're trying to test, and then the one you
Yeah.
create to test it.
So I'm going to write a number down here. So when we count, we start, 0. So I want to say this is 0 position. So when this says 4th bit, you know that this is 1, 2, 3, 4, 5, 6, 7. Okay. So then I'm going to make a mass value. So you want to test that's 1. This bit here. What I can do is, what if I ANDed the value in my one, and if I do 0, 0, 1, 0, 0, 0, 0. So I'm going to AND those two together. So we get 0, 0, 0, 0, 0, 0, 0, 0. So if it's 0, fourth bit is not 1. Okay.
Can't you just look at that and say the fourth bit's not 0?
What if, well, the thing is, the computer needs to test it, right? You have a program, and you want to test the fourth bit. How do we write a program to test the bit?
Then yes, that's not a 1.
Yeah.
So, okay.
Yeah. So basically, this is the way that I can tell the computer, hey, I want to test if my fourth bit is 1. And so I ANDed it with what you call a bit mask, and I can see, oh, I'm 0, I'm not 1.
Why would you do that?
A couple reasons. What if I want to test, let's say, these 0s and 1s are light switches, and I want to test. I'm not in the room, okay, but I want to test if, let's say, these row of lights are on, right? And so I can just take a bit mask and say, this row of lights is on. So I can test, oh, is that row on? And then this way I say, no, it's not. It's not on.
So whatever the bit is, you create a mask that has a 1 in that position and AND it with your number.
Yeah, if I want to test if it's on. See, if I put 0 is a little bit more tricky. If you want to test with 0. But it's the same kind of logic. I mean, if you want to test if this bit's 0, if I AND it with if I put 0 there, then we have to change this. If it's 0, we know that bit is 0.
Do you AND it with all 1s? Or?
Oh yeah, we can do that as well. Let's see. Oh, any with all 1s will do to give us.
If it was a 0, right? It's a 1.
Yeah. I got 1. See, we do all 1s. What happens is we AND it. So we're gonna get 0, 1, 1, 0, 1, 1, 0, 0. See, that doesn't make any sense.
That doesn't.
No, it doesn't. If we OR it, that doesn't give us anything much either, because then now this would be 1, 1, 1, 1, 1, 1, 1. that way, and then we can say, is that equal to the mask? And if it is equal to the mask, we know it's 0. That's the way you mostly see it, is you'll OR it with something and you'll test it against itself, and then you'll know if it's true. If that bit. This is how also you test multiple bits. If I want to test this one here was also 0, so that way I get a 0 here. So that way it's like I tested 2 bits now. I tested the first bit and the 4th bit. They're 0 on this example. I said, oh.
Why couldn't you just AND it?
If we AND, so we're going to get.
You have to change your mask, right? If you AND it.
Yeah, I believe so. 0, 1, 1.
Well, I mean, you'd have to change your mask value to the AND, right? You'd have to change it to the bits you were testing. You want to change those to 1, right? And the rest 0.
So you want to go all zeros here?
Yeah, if you did all 0 and then AND on the ones you are testing, you would get the same value, wouldn't you?
We were testing the first one, right? And
So if you use AND, you have to mask with zeros. If you use OR, you mask with ones.
yeah.
And then the value you want to test is whatever.
Yeah, it's kind of more of like I call it an art skill. You can play around with it.
So you can do either one as long as you.
Yeah, that's basically a good way to say it. I can do either one. It's just your preference. So I've seen it done multiple ways and harder ways, but
Isn't that like the truth tables, just kind of like the discrete structures?
yeah. Another way we can use masking is if we want to turn bits on or off. Hopefully you see that if like I said here, if I wanted to turn, if I use the OR, go back to OR. And if I wanted to turn on this bit, we OR. So basically is we get to keep everything. Now this changes to 1, and this one here went to 1. So basically it's like I turned using this bit mask, if I OR it, I turn these ones on. And if I want to turn it off, we AND it, right? It was 0. So if I want to turn it, this is like say turn bits on, you want bits off. We and it would go whatever. And we want to turn off. Let's say I just want to turn off the bit here. So if I just 0, 1, 0. So if I want to turn that bit off, you see at 1, I get 0, 1, 0, 0, 1, 1, 0, 0. So I just turned off this bit here by using I'm just turning that bit off. So I can just use it just to turn bits on
You're
and off.
ANDing that or ORing that?
I'm ANDing that one. So I want to turn a bit on, I OR it with whenever I want to turn it on with 1. If I want to turn bits off, I want to AND it with 0, the bit that I want to.
So you would replace it with the answer that you got? And
Yeah, I would
wouldn't
replace the answer.
Wouldn't that manipulate the other bits, though? I mean...
No, you see, I want to turn this one off. You notice all these bits are the same These was saying
Oh, I see,
only one
okay.
change was the one I wanted to turn off. And so, the best example is on microcontrollers. We control LEDs, lights, by doing this, or we check switches, like I said, light switches. See if a user hit a button or flipped the switch on the microcontroller. This is how we test on microcontrollers. If the lights are working or what a user did.
And how would you blink it?
What?
How would you blink it?
You just,
Like on and off, on and off.
Yeah.
Just do like a
so I go and or with the mask, just keep going back and forth, yeah. And then there's some timing that you have to go through, but
Do you have to write each line and or do you like and or it and then do like for infinite? You know what I mean? Is there like an infinity or an infinite like loop command? Or, 'cause
yeah,
what
there's
is
an
it?
infinite loop
You know
command.
what I mean? Because that'd be a lot of.
There's an infinite loop command. What if I did while true? If I wrote like while one, it'll always work. It'll always run in that loop. And so, or you do a for loop and you just do for colon colon.
Assembly handles the while, or is it because we do C?
Well, higher level language is lower level language, so if it basically is there. We can do an infinite loop in assembly too. But we'll talk about that in months from now. Okay, so now we can do. We have number representations. Now we're going to go into kind of like the standard data types that we have.